And the goal is to know what a matrix is and how to perform row operations. So in order to solve systems a little more, well, a lot more efficiently, we're going to use matrices. So let's take a look first at what a matrice is. A matrice is a way to organize data. So a very simple matrix would be exactly what you see in those numbers there, and we would use a large bracket to start and end our data, and we would just simply list the data on the inside. So as you can see, I'm just listing the list of data. And so it will have rows and it will have columns. And there are 4 rows. And there are 6 columns. So this matrix would be a 4 by 6 matrix. We do row, then columns. Always row by columns. So that's a very basic definition of a matrix. So we use it to organize data. But we're also going to see matrices here. We're going to work with matrices where we have, and we're solving for systems, as we've talked about. Sorry, it's a little slow, apparently. The matrix that we're going to look at first is solving a system of equations. We'll talk about what row operations are. So let's talk about that. So when we're talking about an augmented matrix, it's a slightly different matrix. That previous one was just like setting up data and putting it in this cute little form. But an augmented matrix is a slightly different matrix. It's a matrix such that it has an equal sign in it. Notice this equal sign here. This is its corresponding augmented matrix. And we put a line down where the equal sign would be, so everyone's aware of the fact that that would be the equal sign. And notice that the 3, 1, 2s, they all represent the number of x's, y's, and z's, because there were 3 x's, 1 y, and 2 z's, so we have 3, 1, 2. So my first column is really representing the number of x's, the second column is y's, and the third is z's. And of course, the final, the right-hand side, is what they're all equal to. Now, the reason these are so helpful is because sometimes we're going to work with the equations and make them look like this. Remember how we always solve for a variable first, like z, and then we find the other variables? Well, what has been learned in math is that if we want to use matrices, we want to get that main diagonal down to 1s. And we'll get zeros on the left-hand side. And that's the math that we're going to be doing in the long run. We're going to start out simple, just making sure we understand basic operations, but we're going to get to the point where we can work with these matrices and save ourselves a lot of time solving systems of equations. This is so this arrangement, that's the most key here thing. This arrangement makes it easy to find the solution to the system of equations. So we're going to work up to that. So let's take a look at the first example. We're going to first start by simple, write the augmented matrix. The augmented matrix of this system would be 3, 4, 7, 4, -2, 5. And of course -2 because it's subtract 2, which is the same as adding a -2y. That's my augmented matrix. Very simple. Now let's try to find the solution using the augmented matrix here. So we first need to rewrite things kind of as x's and y's. So this would be x plus 2y minus 5z equals -19. The other one would say no x's, but y plus 3z equals 9. And last but not least, the final equation is super nice. It tells me z is 4. So I actually have the z value already. So what I would do now I have one of the 3 variables. I'm going to plug it into the second equation, y plus 3 times 4 equals 9. And I will get, looks like I'm going to get -3 for y. So I have my second solution, second part of my solution. Now, of course, I'm going to take both these answers, 4 and -3, plugging them into the first equation to find x. X plus 2 times -3 minus 5 times 4 equals -19. I'm going to solve for x. So I'm going to get x minus 6 minus 20 equals -19. Add 26 to both sides. I get x equals 7. And I have my solution to the system, 7, negative 3, 4. And I'm done. So if we have the system written in this form with ones down the diagonal, notice how quick it became. But we have to talk about how to get there. So how do we get there? We're going to do some row operations, which are comparable to doing elimination steps. So let's talk about what operations are allowed. The operations that are allowed when you're solving and finding a solution to, when you're working with matrices, here are the following operations that are allowed. You may interchange entire rows. So that means that I could swap these two rows out, write the first row as 1, 1, 2, 19, and I can do it 3, 1, 2, second, 31, and 1, 3, 2, 25. This matrix, that's a legal move with this matrix. This matrix is still talking about the same system. Of course, all I did was change the order of the equations and how I wrote them down. Think of it that way. The second thing that's legal is you can multiply an entire row by a non-zero number. You can't multiply everything by 0, but you can multiply everything by 2 or negative 2 or 1. So for instance, I am going to multiply the bottom equation by negative 1, and I'm going to get the following. Okay, no big deal. Second step, the third thing that's legal is that you can add 2 rows to replace another row. But the key here is that you have to add 2 rows and replace one of the 2 rows that you added. Okay, so you can't add row 1 plus row 3 and put it where row 2 is. That would not be legal. It has to go with row 1 or row 3. So I'm going to do that right now. I'm going to add row 1 plus row 3. And I'm going to replace row 3. Okay, so it's going to go where row 3 is. So row 1 and row 2 are going to stay the same, but I'm going to add the top and the bottom and replace the bottom. So the top is going to stay the same. The middle equation is literally nothing's going to happen to that guy. But the bottom, I'm going to add the top with the bottom, and I'm going to combine these 2 lines, and I'm going to put it in the bottom. Now when I add, I'm going to add things that are in the same spot. So 1 and negative 1 make 0. Negative 3 and 1 make negative 2. Negative 2 and 2 make 0. And on the left, I get 19, and negative 25, I get negative 6. So again, all I did was add. I added the top and the bottom equations. The ones, of course, with the negatives. Now I've got a new matrix. It looks different, but it is identical to the other ones. I've just performed an operation. It's basically like I was using elimination and adding 2 things together to make something a 0. Notice one quick thing. Now I would start to swap rows. I would actually switch these 2 because this is getting close to my augmented matrix where I have a 1 in the middle. And remember, I'm sorry, the desired form of the augmented matrix with 1s down the diagonal and 0s over here. That's very similar to this middle row here. If I have 0, negative 2, I'm actually quite close. And we'll work with that in class tomorrow. We're not going to quite do this in the video here. Let's take a look at the next quick thing that we're going to do. So you'll see this in the book. The book will often ask you to perform a certain operation. And it asks you in a way that states R2 equals 4R1 plus R2. And that's saying replace row 2 with adding 4 of the R1s plus the R2s. So I'm going to first kind of multiply everything by 4 here. I'm going to get 4, negative 12, 12, negative 20. I simply multiplied row 1 by 4. Now I'm going to add it to row 2 and put it where row 2 is. So notice I'm actually going to leave row 1 the same. I'm not actually changing it. I'm changing it briefly in my head, typically. I'm going to leave row 3 alone because there's nothing to do with row 3. But this instructions are asking me to do multiply the top by 4 and add it to the middle to get the new middle. So now I'm going to add 4 and negative 4, and I get 0. The next thing I'm going to add is negative 12 and negative 5. negative 17. The next thing I will add is 12 and negative 3 to get 9. And last but not least, I will add negative 20 and negative 5 to get negative 25. I just performed a row operation for this matrix. So that's our first step, is to learn how to perform row operations. Then we'll use them to solve systems. So let's take a look at your checkpoints for this video. That's it. You're done, by the way, with that type of question. So try this with the multiple choice and the free response. And do your best to explain what your matrices would be. When you're filling in the checkpoint, you should be. So I'm talking about question the free response right now. And when you're filling in your checkpoint on the video, just enter between each row. So list the numbers that you have in each row after you perform that operation and hit enter between it so I can see your matrix online. The multiple choice question wants you to find the solution to the system. I'm not actually asking you to use matrices. I want you to find the solution just using elimination and bring in that work to class. That's essential to understanding how to solve it using matrices. We'll finish that problem in class, and we'll talk how to solve it using matrices, but have the worked out solutions to what you did, and then we'll talk about how to do matrices to solve that problem. So thanks for watching, and bring those questions into class tomorrow.